Hello, welcome to this lesson. In this video, we are going to learn about the Bernoulli distribution. The Bernoulli distribution normally deals with binary experiments. Okay, if I say binary experiment, these are experiments that have just two possible outcomes. Okay, so Bernoulli distribution deals with this kind of experiments. Okay, so I'm going to use an example to explain the Bernoulli distribution to you. So assuming I have a coin, okay, and I toss this coin once, okay. The Bernoulli distribution deals with single trials, okay. So I toss this coin once, I can get a head or a tail, right? So these are the possible outcomes that I can get after throwing this coin, okay. It's either I get a head or a tail, okay. So you know that random variables are variables that they are values that are assigned to the outcomes of a random experiment, right? So let's define our random variable x as the number of heads, okay, as the number of heads. Okay, so if I toss this coin, it's either I get a head or a tail, right? So I know that these are my possible outcomes. So let's look at the possible values that x can get. So if I get a head, then we know that our x is going to be 1, because we are just going to have one head. And then if we don't get any head, which is just a tail, then our x is going to be 0, right? So in this case, our random variable x can take 0 or 1. Okay, these are the types of experiment that the Bernoulli distribution deals with. Okay, so it deals with experiments that have just two possible outcomes. The outcomes might be a yes or no outcome, okay, a success or failure. Okay, it might be boys or girls. Okay, so we just do with experiment that have two possible outcomes. Okay, so these are the types of experiment that the Bernoulli distribution deals with. So you know that for every outcome of x, they are going to have a probability, right? So what will be the probability of we getting 0? That means what is the probability of we not getting ahead? And then what is the probability of we getting 1, which is the probability of getting ahead? So for all the values of x, they are going to have probabilities, right? And then that is known as the probability distribution for the values of x. Okay, so Bernoulli says that if we have this kind of random variables, okay, which we are gotten from a binary experiment, then we can find the probability mass function, which tells us the distribution of probability to the random variables as f of x, okay, to be equal to p to the power x multiplying 1 minus p to the power 1 minus x. So Bernoulli says that if you have this kind of experiment, you can find the probability distributions for the variables using this function here, okay, where the p represents the probability of success, okay, the probability of success. In this case, the probability of success means the probability of getting ahead, because our main focus is on getting the number of heads and after the experiment, right? So our probability of success will be the probability of getting ahead. And then there's another value known as q, which is the probability of failure. Okay, I'm going to explain that also to you. Okay, so let's look at what this means. So Bernoulli distribution is saying that if you have an experiment, okay, which is a binary experiment, then we can express the probability distribution function as p to the power x bracket open 1 minus p to the power 1 minus x. Okay, this is what the Bernoulli distribution says. Okay, where the p is for the probability of success and then the q is the probability of failure. Okay, I'm going to use an example to explain this to you. So from this example where we tossed a coin, okay, so from we tossing the coin, you know that the probability of getting a head which is success, is going to be what? 1 over 2, right? So in this case, our P will be equal to what? 1 over 2, because we said what? P is the probability of what? Success. So the probability of getting ahead, which is the same as what? P will be equal to what? 1 over 2, right? Which is the same as what? 0.5, right? And I want to be the probability of not getting ahead. That will also be Q, okay? Which is the same as the probability of failure, and then that will also be equal to what? 1 over what? 2, and then that will be what? 0.5. Okay, so let's look at what Bernoulli says we should do. Okay, so we can go straight forward and then get our P and then Q, right? You can also get Q by just subtracting P from 1, because we just have two possible outcomes, right? And then the sum of their probability distributions should be equal to what? 1. Okay, so if I have my probability of success to be P, and then that is the probability of getting 1, then if I add that to the probability of what? Failure, which is Q, that should give me what? The total probability, right? So if I know the probability of, if I know the probability of success, that means we can get the probability of what? Failure by subtracting the probability of success from what? 1, because the total probability will be equal to what? 1. So from here, okay, I can get this 0.5 here by subtracting the 0.5 for P from what? 1. Okay, that's another way of what? Getting the 0.5 here. So Bernoulli distribution is saying that we can find the probability of failure by subtracting what? The probability of success from what? 1, since the total probability must be equal to what? 1. Okay, so Q, okay, is also equal to 1 minus what? P. Okay, so that's what this means. So now let's go back to this example. So let's take it as we know our P, because the probability of what? Success is what? 0.5, and then substitute it into this formula here, and then use it to find the probability of what? Failure. Okay, so let's look at that. So we have f of x to be equal to p to the power x, right? Multiplying 1 minus p to the power 1 minus what? X. Okay, so you want to find the probability of what? Failure. Okay, given that you know the probability of what? Success, because p would be what? 0.5. Okay, we're able to calculate that straightforward. So Bernoulli is just giving us another way to get the probabilities, okay, because we were able to calculate the probability straightforward here, but Bernoulli is saying that even with that, we can use this as what? The probability distribution what? Function. So let's go ahead. So we have f of x to be equal to what? P to the power x bracket open 1 minus p to the power what? 1 minus x. Okay, so in this case, you know our p to be equal to 0.5, so we are going to have f of x to be equal to what? 0.5 to the power what? X, multiplying what? 1 minus what? 0.5 to the power what? 1 minus what? X. So this becomes the probability what? Mass function. Okay, this becomes what? The probability mass function. So this is what Bernoulli says we should do. So he says that if you have this to be the probability mass function, then you can find the probability of what? Each of the variables using what? This formula here, right? And then we know x can be 0 or 1, right? And then when x is equal to 0, then that's what? Probability of what? Failure. And then when x is equal to 1, that's what? Probability of what? Success, right? And then we already know what our p is from the calculations we did. So let's say you want to find the probability of what? Failure. That means that our x is equal to what? 0, because there is no head. So you are going to have what? F of what? 0, and then this will be equal to what? 0.5 to the power what? 0, right? Bracket open 1 minus 0.5 to the power what? 1 minus what? 0. Okay, so when we do this, we are going to have f of what? 0 to be equal to 0.5 to the power 0. That gives us 1, multiplying 1 minus what? 0.5 to the power what? 1. This will give us f of 0 to be equal to what? 0.5, which is the probability of what? Failure. So I'm going to have Q to be equal to what? 0.5. So this is what Bernoulli says we can do. Okay, this is what Bernoulli says what we can do. Okay, so let's look at the reason why Bernoulli says that the probability of success should be equal to P, and then the probability of failure should be equal to what? 1 minus P. Let's look at that. So we know that our x can either be 0 or what? 1, right? And then Bernoulli has given us the probability distribution function to be f of x to be equal to p to the power x, bracket open, 1 minus what, p to the power what, 1 minus x. Okay, this is what Bernoulli has given to us. Okay, so let's find the probability of what, failure first. If you are finding the probability of failure, that means that what, x will be equal to what, 0, right? So I'm going to have what, f of 0, and then this should be equal to what, p to the power 0 multiplying, bracket open, 1 minus p to the power what, 1 minus what, 0, right? So when we do this, we are going to get f of 0 to be equal to what, p to the power 0 is 1, multiplying 1 minus what, p to the power what, 1. So at the end, you are going to get f of 0 to be equal to what, 1 minus what, p, which is equal to what, q, right? Which is the probability of failure. So if we substitute 0 into this formula here, then you are going to get what, the probability of what, failure. And then if you substitute 1, you are going to get what, the probability of what, success. Okay, that's what Bernoulli says we should do. So let's put in 1 and c. So we're going to have f of 1. We're going to have f of 1. Okay, and then this will be equal to p to the power 1, right? Bracket open, 1 minus p to the power 1 minus what, 1. So at the end you're going to get f of 1 to be equal to what, p, which is the probability of what, success. Okay, so in all, Bernoulli is saying that if you have a binary experiment, which is an experiment with just two possible outcomes, then you can express the probability distribution function, okay, for each of the variables using what, this formula here. Okay, we can use this formula to find the probability distribution for each of the outcomes. Okay, so now let's look at how you can find the mean and variance for discrete random variables that have Bernoulli distribution. Okay, so the mean in this case, okay, is given as what, p, which is the probability of what, success. Okay, so if a random variable x has a Bernoulli distribution, then its mean will be the same as what, the probability of what, success. And then the variance, okay, the variance will be equal to p times what, q, or p times what, 1 minus what, p. Okay, this is what it means. So if a random variable has a Bernoulli distribution, then you can use this to find the mean and then the variance. Okay, this is what it means. So let's take an example. I have two examples here actually, so let's look at the two. The first question says a basketball player can shoot a ball into the basket with a probability of 0.6. What is the probability that he misses the shot? Okay, so a basketball player can shoot a ball into the basket with what? A probability of 0.6. What is the probability that he misses the shot? So what will be our P in this case? He was able to shoot the ball. They said the question says he can shoot a ball into the basket with what? A probability of 0.6. That means that the probability of success, which is P, is equal to what? 0.6, right? And then the question is asking us that what is the probability that what he misses what, the shot, which will what, Q. And then we know that Q, okay, is equal to what, 1 minus what, P, right? Which will be equal to 1 minus what, 0.6, and then this will be equal to what, 0.4, right? Okay, so now let's solve this example using the probability distribution function. Okay, so let's consider the probability of success, which is the probability of the ball being shot into the net, to be let's consider the probability of success to be 0.6, and then what you're going to do is that is either the basketball player is able to shoot the ball into the basket, or he is not able to shoot the ball into the basket. Okay, so let's say that our random variable is equal to the fact that the basketball player was able to shoot the ball. Okay, so x can be 0, which means that he was able to score, or so he was not able to score, or can be 1, which means what, he was able to score, right? So those are the possible values that x can get if we are considering the basketball, if our main focus is the basketball player scoring. Okay, so you know that it's either what, success or failure, right? So if the basketball player is able to score, then that is what, success, and then you are giving 1 to that. And then if the basketball player is not able to score, then that is what, failure, and then you are giving what, 0 to that. Okay, But we already know that the probability of what success is what 0.6, right? That means what our p is what 0.6, right? And then the Bernoulli is giving us the distribution function as what f of x equals p to the power what x, right? Bracket open 1 minus what p, 1 minus what p to the power 1 minus what x, right? So in this case we want to find the probability of what failure, which means that the basketball player was not able to score. And then if we know that if the basketball player was not able to score, then our x is going to be what 0, right? So we're going to have what f of what 0 to be equal to p, which is what 0.6 to the power 0, multiplying 1 minus what 0.6 to the power what 1 minus what 0, right? When you do this, you're going to get f of what 0 to be equal to what 0.4, which is the probability of what failure, or the probability that what he misses what the shot. So this is how to use the Bernoulli distribution function. Okay, so you might actually be asked to find the probability distribution function. Okay, so in this case we know our p to be 0.6, so in general you're going to have f of x to be equal to 0.6 to the power of x, bracket open 1 minus what 0.6 to the power of 1 minus what x. So this becomes what our probability distribution function, where x can be either 0 or 1, and then we know x is 0 when there is failure, and then x is 1 when there is what success. Okay, so this will be the probability mass function, okay, for the question. So now let's look at the second question. It says that if a Bernoulli distribution has a parameter of what 0.45, then find its mean. Okay, so this parameter here is the p. Okay, this parameter here is the p. Let's take note of that. Okay, the Bernoulli distribution deals with what the parameter p, which is the probability of what success. So if you have p to be equal to 0.45, then let's find what its mean. Okay, from here we know that the mean is the same as what p, so in this case we are going to get the mean to be equal to what 0.45.